In this video, we are going to review the Chapter 1 exam for my course. So on the screen, I printed up a practice exam from Math Excel. This is exactly the same process I will use to create the exam that you take. Now, with the COVID-19 pandemic stuff, we're trying to use Canvas to administer exams using the Monitor and Respondus lockdown browser, all that stuff. If that's the case, the problems you will see on Canvas will be taken from the practice exam. If we're back to like normal classroom operations and you're taking your test in class, it'll be on paper and it will be a printed up version of the practice exam. So either way, this is going to give you a really good idea of what to expect on your test. The problems should go in the same order. They're the same types of problems. There is some variability built into some of the problems. So, for example, the word problems that we're going to see on the test, the practice test, there are alternate word problems that could get chosen when I generate the test that I end up giving to you. So it's important, it's helpful for you to take a look at the practice exam yourself. So not only go through the one that we're about to do on the video, but generate your own practice exam from Math Excel, because I give you access to it. It's very much like a teacher giving their students access to the test bank. You have access to my test bank, and so you can see exactly the kind of problems I'm going to put on the test. I'm not trying to hide that information. However, you know how Math Excel works. It modifies the numbers each time you generate it. So the numbers are going to look a little different, even if the problem's the same. But also, as I mentioned on some problems, there's a pool of questions for it to select from. So it'll pick one out of a pool, but they're very similar questions in the pool. Even if the question is slightly different, it should be on the same topic, and done in roughly the same way for most of the alternate questions that could show up. Anyways, let's go ahead and take a look at these questions on the practice exam that I generated. And as I mentioned, in addition to that, if you really want to make sure you're prepared for the test, you should also look at the practice exam on Math Excel a couple of times at least. I find that my best students that do the best in the class are the students that study multiple practice exams and over-prepare for the test in that way. And they generally do pretty well when they do that. So if you want to make sure you're going to get a good grade, that'd be the best way to do it. Anyways, let's go ahead and get started. So the first question is solving an equation. We have 13 plus 6z equals 7 times z minus 1. Pretty straightforward, just get z by itself. The first step would be to distribute the 7. So I'm going to distribute into the parentheses. The left-hand side isn't changing, so I'm just going to copy it over. 13 plus 6z equals 7z minus 7. And then I want to get z to one side, the numbers to the other side. So I'm just going to go for the standard play here, which is we'll get z on the left-hand side. Excuse me, my ear started itching all of a sudden. And so we'll just do one step at a time. So we'll do that first, and we will get 13 minus z, right? Minus 1z if you want to put a 1 there, but 6z minus 7z is just going to be 1z, negative 1z, excuse me. These cancel out, but we'll still have a negative 7 left over here. All right. Next, we will subtract the 13 to the right-hand side. So I'll continue up here, and we are going to have negative z equals negative 20. And then finally, to get z by itself, I'll divide by negative 1. So again, if you wrote the 1 there, that's fine. If not, it doesn't make a difference either way. You're dividing by negative 1 at the end, and we'll get z equals positive 20. Sorry, excuse me, I just had lunch, so feeling a little bit of indigestion. Okay, question number 2. Solve this equation. Now, this one's one of the more challenging problems in Chapter 1. It's a rational equation, or an equation involving rational expressions, maybe is a better way to describe that. And we talked about this in section 1.1. The process for solving this kind of equation is to find the common denominator, multiply it to both sides to get rid of the fractions, and then solve whatever you end up getting after that. To find the common denominator, you have to factor these denominators. The first one can't be factored. It's just w minus 3. So you want to factor all three of them, but I didn't underline the first one because, again, my mind just automatically checked it off my list. It can't be factored. It's just w minus 3. So I'm just going to copy that over. 1 over w minus 3 minus 2 over, this can be factored by factoring out a common factor of 3. So I'll factor out a 3, and I'll get w minus 3 left over from that, equals 1 over, same thing here. Factor out a 3, we get w minus 3 left over. The common denominator, which is called the LCM, least common multiple, of these denominators, you take every factor that occurs. 3 is a factor, so that needs to be in my common denominator. It occurs twice, but you just have to write it once in your common denominator, that's it. And w minus 3 is also a factor. And it occurs 3 different times, but we just need to write it once in our common denominator. And technically you want to raise each factor to the highest power that occurs, but what is most often the case with these problems is the factors are all to the first power. So you don't have to worry, so these will just stay to the first power as well. So that step can kind of be ignored. So we will multiply this to both sides of the equation. So here's kind of a lazy way of doing that. See if I can undo that mark there. So like this. I'm going to multiply, I forgot the 3. Let's try that again. 3 times w minus 3. All right. And so we're going to multiply that to both sides of the equation. So this will get multiplied to the left-hand side, in which case it's going to be distributed, and it gets multiplied to the right-hand side. Think of this as being over 1, since it's going up against all these fractions, so you can kind of line things up a little bit better, and you're better able to see what cancels out. When this gets multiplied to the first fraction, the w minus 3's are going to cancel out, and I'll just have 3 left over. 3 times 1, which is 3, divided by 1, which will still be 3. Now I'm going to undo the crossing out here because a fresh copy of this has to get multiplied to these other two, so I don't want to mark on my original copy of my common denominator. So I'm just going to keep that clean, but just remember that it gets multiplied to each factor, so you don't want to really mark on this one. So we're just kind of mentally imagining this. W minus 3's cancel out. What's left over? As we mentioned, it's already, sorry, I'm getting my words scrambled. As I already mentioned, it's just a 3. All right, so we're going to have 3 left over here, minus, same thing happens here. This gets multiplied to the next term. The w minus 3's are going to cancel out, but also the 3's are going to cancel out. So what's going to be left over here is a 2 on top, divided by a 1 on the bottom. 2 divided by 1 is just going to be 2. And if you're starting to get worried, like, wait a minute, all the w's are going to cancel out, you're absolutely right. So this is sort of an unusual, I don't know. I want to say it's an unusual outcome, but with this particular textbook on Math Excel, this is actually pretty common for this kind of problem. It should be unusual, but it seems to happen quite a bit with the problems they make available. So lastly, this gets multiplied to the last fraction, which is over here on the right-hand side. The 3's will cancel out, the w minus 3's cancel out, and we get 1 divided by 1 left over, which is going to be 1. And so we get that. And yes, indeed, your variable just disappears, which means it's a special case. This means either there are infinitely many solutions or there are no solutions at all. The way we determine which of those two is the case is by looking at the final result. So I'll go ahead and finish simplifying here. 3 minus 2 is going to be 1. And I get 1 equals 1, which is true. So if you get a true statement, if your variable disappears and you get a true statement, that means there are infinitely many solutions. If your variable completely disappears and you get a false statement, that means there is no solution. And so that's how you tell the difference between the two. Now, you might be thinking, okay, Mr. Fallon just showed me on number 2, it's going to be infinitely many solutions, so I'll just answer that on the test, and I won't have to bother like showing my work or actually knowing how to do the problem. But that isn't going to work for a couple of reasons. One reason is there are alternate questions. So this particular version of the question turned out to be infinitely many solutions, but it's possible there is an alternate question of the same type, so it's going to look the same as what we did just now, but ends up being false at the end, in which case you would want to select no solution. So you really can't be certain that this one always works out to be infinitely many solutions. Now, maybe you investigate and you look at multiple practice exams and you find on every single one of them that it's always infinitely many solutions. That could be the case. I honestly can't remember if I have alternates in there with different outcomes. I think I do. But it is possible maybe on some of these problems they'll be predictable like that, where my test bank doesn't have enough variability built in and the answer it's the same answer every time, for example. But if you heard that boom, it's July 5th, so people are still shooting off their fireworks. It's middle of the day, middle of the afternoon, but people are still doing fireworks. So I require my students to show work on the test because I am sort of paranoid about that, because I agree. There are going to be problems where you can just kind of memorize the answer from the practice test without really learning how to do the problem, and I'm not okay with that. So I will require that you show your work. And if you don't have the work here, so if you pick the right answer down here, infinitely many solutions, but you have no work to support that answer on your test, I will not give you any credit for the problem. So you have to show your work on the test. So don't just try to memorize answers from the practice exam. That is not a good strategy. I will not give you credit. I will ask for an explanation. You'll get a chance to explain to me how you got that answer. Most students don't follow up with me on that because they don't really know how to do it, because they never learn. They just memorize the answer from the practice test. So don't approach it that way. Learn how to do the problem and understand the steps so that you can do this problem when you take the test. All right, so this is true. Infinitely many solutions. All right, but here's another decision we have to make. A is not correct because A is the answer you would pick if there was a solution. So if you get, and I'm pretty sure I've graded exams where sometimes you do get an answer here. So it's not even, oh, maybe it's infinite, maybe it's no solution. I'm pretty sure I have a problem on the test like this where it works out and you get x equals 5 or something like that. If that's the case, you choose answer A and you put 5, right? If that's the answer you get, you type it in for the answer for option A. D is the answer you would pick if there was no solution at all. So that's not the case either. So B and C are both for infinitely many solutions. C is the answer you would pick if it were infinitely many solutions without any exceptions. So if all real numbers are solutions to this equation without any exception whatsoever, then C would be the correct answer. But there actually is an exception in this particular problem. So anytime you have an equation that's a fraction with variables in the denominator, so I say the equation is a fraction, that was really poor wording on my part. If you have an equation with fractions and variables are in the denominator of that fraction, you have to be careful not to divide by 0. And you have to be careful that any solutions you accept do not run afoul of that limitation. And so if you get an answer that would make your original equation have a 0 in the denominator, it is not an acceptable answer. You have to throw it out. You have to eliminate it. You have to omit it, right? For these denominators here, after you factor, it becomes pretty clear that they all have the same limitation. They all have this w minus 3 in the denominator, and the limitation there is that you don't want to use 3 for w. Because if you plug in 3 for w, you'll get 3 minus 3, which is 0. 1 divided by 0 is an issue. It's broken. It does not produce a result, so it's not a valid number to use in that equation. And it's the same for these other denominators as well. If I plug in a 3 here, 3 minus 3 would be 0. 0 times 3 is still 0. And so you get 2 divided by 0, which is a problem. And so all three of these denominators suffer from the same problem, which is you cannot use the number 3 for the variable in this equation. And so there's an exception. So there's infinitely many solutions, but 3 is still not an acceptable solution. And so we need to note that. We need to note that in our answer. And so that's when you choose option B, which is saying that the solution set is any number w that you want, such that w does not equal blank. So except for these numbers, basically. W can be any number except for these numbers I'm about to list. And we're going to put 3 here. So any number but the number 3. Still infinite, but with some exceptions. All right. So I'm sorry for the diatribe there about how to study and, my expectations. But I just want to make it clear that, because some students will have that strategy. The way they study for the test is to look at the practice exam, memorize what they can without having to learn how to do the work. And I think some of those students could do the work if they took the time, but they are more focused on test-taking strategy of just getting the right answer, which is maybe a good strategy if you're taking the ACT and you can just figure out the right answer without really knowing how to do the problem. That's fine on the ACT, right? That's going to get you a good score, but not on my test. I'm not going to accept those kind of answers. So there are problems on the test. I don't know about this one in particular, but on some tests where there's not much work to show on certain problems, and I'm willing to let those go. I mean, I'm trying to think of an example, but like in chapter 2, for example, you'll be asked, is this thing a function, yes or no? And there's ways to justify it, but I don't usually ask my students to do that for those problems. It's just a yes or no problem, and I just give it to you if you get it right. Even though it's 50-50, you might just be guessing. It's not a good strategy because there's like 4 of those problems. So if you're guessing on every one, probably only going to get half of them right. But where, like solving equations, where there are steps, I expect to see steps leading to the answer. Where there's a difficulty with going from one thing to the other, I expect some justification on how you got from here to here, because for example, on this problem, if you just say, oh, it's infinitely many solutions, that's not an automatic conclusion. You can't just tell by looking at the equation that would be the case. It requires some justification. Some work has to go into showing that it's infinitely many solutions. So it's more of a philosophical thing, and I can understand the approach of, test-taking strategy. If I'm trying to study for this test, I want to get the highest grade possible, which means just getting the right answer. So I'm just going to focus on what's the easiest way to get the right answer. But that is not what you should focus on, because that will not get you the highest score on the test. What will get you the highest score is learning how to do the problem and showing the steps, justifying your answers. Even if you end up getting the wrong answer, I will give you partial credit, but you need to show work. And if you're not showing work, you're not going to get the highest score possible. So what type of equation did we just deal with? Well, if there's infinitely many solutions, then it's an identity. So that's how you tell which answer is correct here. Sorry, I'm doing a bad job of writing an X. It's a conditional equation if you got an answer. So if you got x equals 5 as your solution, it'd be a conditional equation. And it's inconsistent when there's no solution. All right. So I'm already 18 minutes into this thing, and I've only done 2 problems. I'm maybe doing a little bit too much philosophizing and not enough reviewing of the problem. So I will try to stay more focused from here on out. Solve this equation, absolute value equation. First step, get absolute value by itself, which is already the case. Second step, we're going to split this up into 2 equations. The first equation is an exact copy of the original. The second equation stays the same essentially. The only change you make is taking the negative of the right-hand side. The left-hand side should not change at all. Again, the reasoning here is that the way you get the absolute value to equal 2 is either this thing here has to become a 2, because the absolute value of 2 would equal 2, or it has to be negative 2. Because the absolute value, if this becomes a negative 2, the absolute value of negative 2 would also equal 2. So when does this equal 2? That's what this equation will tell me. When does this equal negative 2? That's what this equation is going to tell me. So that's why we're setting it up in this way. I'll maybe continue the first one over here. So let's just rewrite it. So I want to solve this one for x. I'm going to add 1 to both sides. I get 4x is equal to 3. And then we divide by 4 on both sides. And we get x is equal to 3/4. I feel like I'm not happy with how I wrote that fraction. Let's try it again. 3/4. That's better. Okay. That's one solution. The other solution we're going to get from this, so I'll just write it up over here. We are going to solve it for x by adding 1 to both sides. And you should find that whatever steps you took over here should be taking the same steps over here. Right? Adding 1 to both sides, just like we did over here, I get 4x is equal to -1, and then dividing by 4 on both sides, just like I did over here. Divide by 4, excuse me, I'm talking funny for some reason, and you get x is equal to -1/4. All right, and so that is how you do number 3. You get 2 solutions, both of them, and if it's on paper, if you're writing your answer out on paper, which is most likely what you're doing, you don't have to, if you have this printed up, like if we're in class and you're taking this test in class, you don't have to write it in this space here. You can just leave it wherever it is on your paper, and that's fine. All right. Number 4, solve this for x. So I want to get x by itself. The first step here will be to subtract the hy to the other side. So we're going to get dx equals j minus hy. And then to get x by itself, you divide by d. And that's it. You get x equals j minus hy over d. Okay, make sure you show your steps on that problem. The last problem on this page is number 5. Cameron and his friend John bought a used circus carousel for $41,430, including sales tax. If the sales tax rate is 6%, then what is the cost of the carousel before tax? So in my lecture video for section 1.2, I did a similar problem. It wasn't the same, but it was similar, and it had to do with a car auction. So buying a car at an auction for a certain amount and then having a 10% buyer's premium added to that amount and getting the total from that. And then trying to work backwards to what the original bid was. This is a tax rate problem, and this is a really common type of word problem. My suggestion for solving it was to use words to set up the equation. So we have the price of the carousel plus the tax that they had to pay on it, the sales tax, equals the total amount that they have to pay, right? So when you go to buy something, whether it's at a store or wherever, you'll see, at least in the United States. Now I know in other countries they have different rules for providing this information. And in some countries, the price you see in the store is how much you pay with the tax already included, but not in the United States. So when you go to the store in the United States, the price you see on the shelf is before tax has been added. So you take the item you want to buy at the store, you take it up to the register, they ring it up, and the amount you pay at the register is going to be higher than what you saw as the price on the shelf, because at the register, they will then add the tax to your amount, and then that determines your total, right? So there's the price of the item on the shelf, then there's the tax, the sales tax that you have to pay on that item, together gives you the total amount that you have to pay at the register, right? So that's what's going on here with Cameron and John buying this carousel, right? The price of the carousel is one thing, but then once you add the sales tax to that price, you get this other thing, which is the actual amount that they're going to have to pay. Right? Now we know the amount that they have to pay. That's given to us in the problem, so we don't need a variable for that. The total amount they ended up paying was $41,430. What we don't know is the price of the carousel. How much were they selling it for? We also don't exactly know the dollar amount of the tax. We know something about the tax. We know the tax rate is 6%. And so some students will just put 0.06 here. Now, if you set up your equation like this and you use words and you make a mistake after this point, you're still going to get at least a couple points on this problem because you're showing good progress if you've made it this far. But for the tax, you can't just put the percent of the tax, because the equation, if this is all you put, the equation interprets that as the tax was 6 cents. It interprets this as a dollar amount because everything here is ultimately in dollars, right? The total's in dollars, the price is in dollars, and so the tax has to be a dollar amount as well. But the 6% isn't a dollar amount, not by itself. A percent really is a unitless number. To make that into a dollar amount, we have to multiply that percent to some amount of dollars. Then we get a dollar amount for the tax. How do we calculate the tax? It's 6% of the price of the item, right? So it's not 6% by itself. It's 6% of this thing. But we don't know what that is. So this is the thing that we will represent with a variable. We'll call that X. And then for the sales tax, we want to take 6% of that thing. We want to take 6% of X. And so that's how you should set up this equation. So by converting these words into numbers and variables, the equation emerges, right? Because we already basically set up the equation with the words. So once I replace the words with math, it becomes an equation that I can solve. Right? Now I can solve it. These are like terms, so I'll combine these together. This is like having 1x plus 0.0x. Sorry, I left out the 6. 1x plus 0.06x. Add those numbers together, you get 1 plus 0.06, which is going to be 1.06. And then the x part stays the same, right? You just copy the variable part down. And that's equal to that. And it's a very easy equation to solve. You'll want to, I mean, it's easy to solve, but not easy to compute. You need a calculator for this. So you'll divide by 1.06. And you don't really need a fancy calculator, just anything that'll do a simple division will work. And so we get 41430 divided by 1.06. And we get $39,084. And because it's money, now this says round to the nearest dollar, but I usually go ahead and round to the nearest penny. And so it's going to be 0.90566. So this is what I got originally. The 5 means I round this up to a 1. And on paper, this would be fine. I'm not going to count this wrong because you didn't round it to the nearest dollar, because it's very sensible to round to the nearest penny. So I'd be totally fine with this. But if you want to get it right on Math Excel, so if you're typing this in as your homework problem, or on the practice exam, if you're typing it in to see if you're getting the answer right, this will be counted as incorrect. So the 91 cents means we're going to round this up to a 5. So this will be 39085, be the final answer there. Rounded to the nearest dollar. Okay. Number 6, a person X can clean up all of the crime in a city in 10 hours working alone. Person Y can do the same job alone in 12 hours. If person Y starts crime fighting at 8 a.m. and person X joins him at 9 a.m., at what time will they have all the crime cleaned up? So going back to my previous point that I was making on question number 2, I get a lot of students on the test with this problem that don't show their work. They just put 1 p.m. And I think that's because that's the answer we got in class. So we actually did this problem in section 1.2. So if you go back and look at that lecture video, you'll see a very similar example of this problem. Same details, just the numbers might be a little different, but same, person X, person Y stuff, crime fighting, all that stuff. And of course I do this in class as well, in my face-to-face classes. And the answer for that particular problem in the video was 1 p.m. And it is possible that maybe when you did the homework, a lot of students get 1 p.m. again, because this problem's on the homework, and they end up getting 1 p.m. again as the answer on the homework. And then I don't know what answer we're going to get today on this particular version of the problem. But it might not be 1 p.m. I have seen different answers. Sometimes it's 11 a.m., sometimes it's 4 p.m. But I will say that most commonly it seems like 1 p.m. is a pretty common answer for this problem. But again, even if that ends up being right, if you have no work to support that answer, I will not give you credit for that. So you need to know how to set up the problem and work towards getting that answer if you want to get credit for it. So don't just put 1 p.m. here. If that's all that's on your test, it might not even be right, but even if it is, you still wouldn't get credit for it if you're not supporting your answer with work. All right, so the way you're supposed to do this problem is to set up a table. It's the way we did it in section 1.2. And you'll want 2 rows because the formula we're using will apply to 2 people. It applies to person X, which is Batman, and it applies to person Y, which is Robin. The formula we're applying here is R times T equals W. So person X cleans up all the crime in a city in 10 hours working alone, which means his speed is 1/10. He gets 1/10 of the job done per hour. That's how fast person X works. Person Y can do the same job alone in 12 hours, so person Y's speed is 1/12. He gets 1/12 of the job done per hour. That's how fast person Y works. Person Y starts crime fighting at 8. Person X joins him at 9. So we don't know how long they're going to be working for on this particular day where they're working together. But I do know that person Y starts an hour early. And so if I let X represent the amount of time for person X to, not get the job done because they're not working alone, but if I let X represent the amount of time that person X will be working this day, then person Y will work that same amount of time plus an hour more because they started an hour earlier. So Robin got up and started crime fighting an hour before Batman got out there and joined him, right? And so they'll finish at the same time, right? When the job's done, the job's done. They both quit. They'll be finishing the job up together at the same time. But when that happens, Robin will have worked an extra hour more than Batman because of that earlier start time, right? And so Robin's time will be an hour more than Batman. So whatever this time is, Robin has that same amount of time plus 1 hour more than that. Once you get these first two columns filled in, you multiply across, right? So we're going to multiply these together to get the work. And so Batman's work, person X's work, is going to be 1/10 X. That expression represents the amount of work Batman's going to contribute to the job getting done. For Robin, it's 1/12 times X plus 1. Because I'm multiplying these two together to get that. And that represents the amount of work that Robin or person Y is contributing to the job that day. And then what do I know about the work that they're doing? Well, together, if I add them up, it adds up to one job getting complete, right? They'll have one city free of crime between the two of them, right? If I add the work they're both contributing, they both contribute enough to get one job done. All right, I hope I'm saying that well. So we're going to get 1/10 X, that's person X's work, plus 1/12 times X plus 1, that's person Y's work. Together they get one job done. So there's my equation. When we covered this problem, and you might notice like some of these are repetitive, like we did this problem already in the lecture, and then you also saw it on the homework. That's going to be a common story for a lot of these problems. What we did in the lecture was to distribute the number into the parentheses first. So we get 1/10 X plus 1/12 X plus 1/12, right? Because 1/12 times 1 is going to be 1/12. Then we find a common denominator because we have a lot of fractions we don't want to deal with. So let's get rid of them. The common denominator for 10 and 12, these are both 12. So 10 and 12 are the only two numbers to consider here. The common denominator, that one's kind of tough. You might think 120 because 10 times 12 would be 120. And if that's what you come up with, go with it. It gets the job done, but it's not the least common denominator. So it's a little bit harder to figure out, but the least common denominator is actually 60. 60 works with 10 and 12, right? 10 divides into 60, 12 also divides into 60. And so we will multiply 60 to both sides. So I'm going to do it like this. Multiply 60 to both sides. We have to distribute it so it gets multiplied to every term. And it also gets multiplied to the right-hand side. So even though that's not a fraction, we have to multiply 60 to that as well to balance out the equation. So think of this as 60 over 1. We're going to end up getting, now what happens here, because it's hard to see, but there's a 1 here, right? So it's 60 times 1/10, which is no different than 60 divided by 10. 60 divided by 10 is going to be 6. The X copies down. Plus 60 times 1/12 is just 60 divided by 12, which is going to be 5. And then the X just copies down. Same thing here. Right? We're going to get 5 equals 60 times 1 is going to be 60. So there's my equation. We will combine these together. So I get 11X And while I'm at it, I will go ahead and subtract the 5 over, and we are going to get 55. And then we divide by 11 on both sides. Sorry, it kind of glitched on me there. Divide by 11 on both sides, and we get x is equal to 5. So if you made it that far and you get x equals 5, that's super impressive. It's not an easy problem, and you got the right answer, essentially. But they want us to take that result and find the time of day that the job will be done. This is not the time of day. It's not 5 p.m. that the job is done. This is 5 hours. It's 5 hours for person X. So person X will end up working 5 hours before the job is finally complete. Person X starts at 9 a.m. They will be working for 5 hours. So what's 5 hours from 9 a.m.? It'll be 2 p.m. So you see, this time it wasn't 1 p.m. So even if you notice that answer happening frequently, it isn't always going to be the right answer. This time it was 2 o'clock. All right. But even if you do guess the right answer, again, just it's not worth guessing, because if it's a guess and there's no work, you won't get full credit for the problem. All right. Okay. Now I kind of marked on my space here for the next problem, but I think we don't really need a lot of room for this problem. So first thing I would do, you don't have to do this, but it just bothers me to see it like this, is I want to move this thing back over to the left-hand side so it can be with x. Because we're talking about a circle here, so notice the directions say circle. And the equation of a circle, which you need to know for the test, is x minus h squared plus y minus k squared equals r squared. All right, it's the Pythagorean theorem. A squared plus b squared equals c squared, right? It's just, instead of a, b, and c, we have some special customized notation there that applies to circles, all right? And that means having x and y on the same side of the equation. So I want to add this back over. I'm going to add the y plus 2 squared. This part doesn't change. This is what changes right here. We're subtracting, so to cancel out that, I will add by this thing. But this part should stay the same when you add that, so that they'll cancel each other out. So I'm going to add that to the other side. So we're going to get plus y plus 2 squared equals 25. Then we want to make that comparison between the formula and the problem I currently have. And by doing that, we can see that h is equal to 0, right? It's just not there. There's no h here, so that means it's equal to 0. K is equal to negative 2. So remember, because of this minus sign in the formula, the value for k will be the opposite sign of what you see here in the equation itself. So because we have a plus 2 on the y, that makes k a negative 2. And then we have r squared instead of, sorry, I'm saying the wrong thing. We have 25 instead of r squared, which means r squared is equal to 25, which means the radius is equal to 5. So the radius is 5. The center is at h comma k. I guess this took more writing than I thought it would, or maybe I just made it worse than it had to be. But the center is at h comma k. So here's h, here's k. So the center is at 0 comma negative 2. So there's the radius, there's the center. If that's all you do on the problem, you'll get like 3.5 points out of 5, because that's really most of the work right there. But the directions are to graph. And so it says find the center and the radius, then graph it. So here's the center, here's the radius. That's 2/3 of what we were asked to do. The last thing was to graph. You'll start by marking the center, which is 0 comma negative 2. And then the radius is 5, so you want to find all points 5 away from the center. The easiest ones to measure the distance for are vertical and horizontal. So I'm going to go 5 up, which takes me to 3, not negative 3, but 3. 5 down, which takes me down to negative 7 from the center. 5 to the left, which is going to take me out to negative 5 on the x-axis, but you have to line it up with the center, right? Because you're going completely horizontal. I get a lot of students that mark the point right here because they go 5 to the left, but they're looking at the x-axis, and that's where they mark their point on the x-axis, but it shouldn't be on the x-axis, right? It needs to be level with the center. And then 5 to the right of the center, which puts it right here. And so now I have these 4 points that are 5 away from the center. And then from that, we are going to try to draw our circle. So these 4 points are my guidepost. And I just try to draw a circle connecting those 4 points together. So here we go. This is probably not going to look very good. I'm not going to even try to redraw it. It's going to look horrible. But I don't want to spend 10 minutes trying to draw this circle better than that. So that's what your graph should look like, except it should be more circular than what I've drawn. All right. Number 8 is another problem about a circle. Here, we're being asked to find the equation of a circle given the center and this point that the circle passes through. So I already have the formula here on the screen, so let's just work off of this. The center is at 5, 4. So that's going to be my h and my k, which I can just go ahead and immediately plug into the formula. Now, when you're plugging numbers into the formula, you don't have to change the sign of the numbers. The formula does that for you. It's only when you're extracting numbers out of the equation that you have to remember to change the sign of the number, because the formula doesn't automatically take care of that. So let's do number 8 right here. We'll have x minus h, which is 5, plugging in 5 for h, squared, plus y minus k, which is 4, squared, equals r squared. Now, we don't know the radius. It wasn't given to us. But the radius, by definition, is the distance between these 2 points. So if I wanted to, one way to find the radius would be to use the distance formula and calculate the distance between these 2 points. That would be your radius. But there's an easier way to approach it without having to think of a whole separate formula. It's not really a separate formula, but to think of it as like a whole separate problem. We can actually just find the radius within the problem we currently have going. And that is by taking the point they give you, temporarily plugging that in for x and y. So I'm going to plug in 0 for x. I'm going to plug in 3 for y temporarily. So this is not permanent, but just long enough so that I can solve for r, right? So I'm going to plug in 0 for x. And I'm going to plug in 3 for y. And I'm sorry, I put the double line there, which maybe was a bad idea. Because it looks like an equal sign. And now, with numbers plugged in here, the only letter remaining is the letter r. So I can solve for r now by just simplifying this and then taking the square root of both sides, right? So let's go ahead and simplify this. We will have, this becomes -5 squared plus, sorry, that looks like a y, but that's a 4. This is going to become -1 squared. Make sure you square these numbers first and add them together first before you do the square root. All right, so this is going to become 25 plus 1. And what I get some students doing on the test is they take the square root. Square root of 25 is 5, square root of 1 is 1, 5 plus 1 gives you 6, and they think the radius is 6, which is incorrect. Because when you take the square root, you can't just take the square root of these individually. If you're going to do the square root of both sides of the equation, you'd have to do the square root of the whole thing. And again, it doesn't split up and apply individually there. So to avoid making that mistake, just don't take the square root yet. Add these together first. 25 plus 1 is 26. And then take the square root. Take the square root of both sides. And you get, it's not a nice answer, but it is what it is, right? You get square root of 26 as the radius. All right. So that's my radius. Now, I forgot that actually, I don't usually like to go that far with it. But I didn't catch myself. I felt like I was just focused on finding the radius, but I forgot what we're really trying to do is find the equation, not just the radius, but find the equation. The equation wants r squared here. Now there's nothing wrong with what we did. You take r, you plug it back into your formula, go back to having your variables, right? So there's an arrow there. Plug that in for r. Go back to having x and y. So don't leave these numbers plugged in. You're done with them. You go back to having your variables, but now you have this new piece of information you can plug in for r. So, and what happens? When you plug in square root of 26 here for r, you square that. The square is going to cancel out the square root, and you'll just get 26. And so that's the right answer. But what you could also do instead is this. Don't take the square root of both sides here. Just stop with this. R squared is 26. Replace the R squared with a 26, right? I'm taking out R squared, swapping in 26 in place of it because my information tells me that R squared is the same as the number 26. So it's a weird substitution, but I'm not plugging in 26 for R. I'm replacing R squared with the number 26. And I don't need to square this 26 because it was already squared, if you will, right? This is the radius squared. It doesn't need to be squared again because it's already been squared. 26 is what you get when the radius has been squared. Right? But if that bothers you, then just do how we did the first time. Solve it all the way down for R, plug that in here. You get the square root of 26 squared. The 2 and the square root cancel each other out, and you'll get 26 there either way, right? And so the left-hand side is going to stay the same. Nothing's changing over there. And so that is the equation of the circle that has a center at 5, 4 and passes through the point 0, 3. All right. And I forgot there was one more problem. I meant to leave this space available for this last problem here. Number 9. Find the equation of a line containing the given pair of points. So we have 2 points here, but it's not a circle this time. It's a line. So make sure you're paying attention to the directions. To find the equation of a line, we use the formula y equals mx plus b. Right? And so the first step here is to find the slope. Right? We need to know m is equal to before I can get started with this formula. And so we'll have to use a different formula for finding the slope. Right? M equals y2 minus y1 over x2 minus x1. This is my first point, so I'll call this x1, y1. This is my second point, so I'll call that x2, y2. And then I plug the numbers in the way I have them labeled. And so I think let's see, how do I want to do this? I kind of messed myself up here. So let's do this first. So m is going to equal y2, which is -1, minus, because there's a minus sign in the formula, y1, which is -8, over x2, which is -3, minus x1, which is -5. And so that's going to be -1 plus 8 over -3 plus 5, which is going to be 7 over 2. So there's our slope. We will plug that in for m into this formula here. So we're going to get y equals 7/2 x plus b. The last thing we need to do is find b. We don't know what b is equal to. B, remember, is the y-intercept, which was not provided to us. Neither of these points is the y-intercept. So to find b, we'll do the same thing here that we did in number 8 for finding the radius. When there's one constant left to find, then all you have to do is plug in a point for your variables, and then you can solve for that one last remaining bit of information. It's the same thing here, right? We have our variables. There's just one more constant value that I need to find. To find that last constant, all I have to do is plug in a point for x and y. Then I can solve for b. I have 2 points to choose from. I'm actually going to choose the second point because the numbers are smaller. And so I'm going to plug this in for x and y, just temporarily like we did over here, so that I can solve for b. Right? So in place of y, I'm going to plug in -1. And in place of x, I'm going to plug in -3. Let me make a little more room this way, because we still have the plus b right here. Plus b just copies down. And unfortunately, and this is what happened when we did this problem back in section 1.4, it's a fraction that doesn't really resolve very nicely. So think of this as -3 over 1. Nothing cancels here. So you just have to multiply the tops together, multiply the bottoms together. So we're going to get -1 equals -21 over 2 plus b. And then we will add, to get b by itself, we'll add 21 over 2 to both sides. Think of this as -1 over 1 because we're dealing with a fraction. So think of both of your numbers as fractions. And we're going to have -1 over 1 plus 21 over 2 equals b. Oh, okay, I'm not really happy with how that turned out. Okay, there we go. And we need a common denominator, Right? The common denominator will be 2, so I'll multiply 2 to the top and bottom here. So I get negative 2 over 2 plus 21 over 2 equals b, which is going to give me 19 over 2, right? Because the way you combine these fractions together is you add the numerators. Negative 2 plus 21 is going to be 19 over the common denominator of 2. So b is 19 over 2. Now that we know what b is equal to, we can plug it into our formula. It's just off the screen. Unfortunately, I can't have both on the screen at the same time, but we're going to plug it in here. All right, so I'm going to scroll down just so we can see what b was equal to. I'll draw an arrow, but it's going to go to something you can't quite see just yet. So I'm taking 19 over 2, plugging it in here for b. Again, I'm done with these numbers. I'm back to my variables, right? I want x and y there, but now I have this new piece of information, b, so I'm going to plug that into my formula now, and I get y equals 7 halves x plus 19 halves. And that's the equation of the line that passes through those 2 points. All right, let's take a look at the next page. Okay, so graph using the equation. Graph the equation using the slope and the y-intercept. So again, we're going to use the formula y equals mx plus b to help us figure out the slope and the y-intercept. Oh, that's really horrible and hard to see. Let me just write it down here. And so we can see by comparing this equation to this formula, they're already set up identically to each other, so it's already in the right form, which saves us a lot of time, because if they had given us the equation in some other form, we'd have to solve it for y first. But it's already solved for y, so we're going to be able to jump right into finding the slope. The slope is the number in front of x, so the slope is 9 over 7. And b is the number that's by itself. It's the constant term. So b is equal to 2. So what does that tell me? It tells me a point. So b equaling 2 tells me that the point 0, 2 is on the graph, right? Because that's the y-intercept. Right? So b is the y-intercept, which tells me the point 0, 2. How do I want to say that? So remember, the y-intercept is a point that has to be on the y-axis. To be on the y-axis, the x-coordinate has to be 0. So it's implied, by saying this is the y-intercept, it's implied that the x is 0 and that this is the value for y. And so 0, 2 is the point that you get from that information. The slope, we want to think of this as rise over run, and the slope gives me directions for finding another point. So I can start at 0, 2, and then from there, I use the slope to find a second point. And then once I have 2 points, I can graph the line, because all I need are 2 points to graph the line. And so the top number is a 9. It's positive. So that means we are going to go up 9. The bottom number is 7, which is also positive. So that means we will go to the right 7, starting from this point 0, 2. So starting from here, we're going to go up 9, which is going to take me up to 11. So that's going up 9, positive 9. And then we're going to go to the right 7, which is right here. So I want to go to the right 7. And I don't know if I quite measured that out exactly where we want to go. Sorry, I'm really having trouble seeing it on my screen. I think it's right here. All right, it lines up with 11 and 7. Perfect. So that is another point that has to be on the line. So we figured out 0, 2 from the equation. We use the slope as a set of directions to find another location that has to be another point on the same line. And now that we have 2 points, we can graph this line. All right, so let's go ahead and graph it. Let's use a different color here. So we're going to go from this point here. It needs to go through both points. And this might look a little broken because of the way I'm doing it. It actually turned out pretty good. But it has to go in both directions, right? Whoops, didn't mean to do that. Goes in both directions. So it doesn't just go from this point to the right. It also goes back to the left. And it should be along the same continuous line. So that's the graph. All right. So that one didn't take too long. Now, number 11... I have this problem on here. I used to have, I don't see it anymore, so I must have cut it out. Because this test, you can tell, like, this is a review video. I'm already at 55 minutes. Some students think, well, if it takes you 55 minutes to review, I'm only halfway. So if this takes you a couple hours to review, how do you expect me to get the test done in that amount of time? But, I've spent a lot of time talking about other things, not just focused on doing the problem. So if I really just buckled down and just did the problems as quickly as I could, it wouldn't take me 2 hours. It's really designed to take an hour. So 50 minutes, because that is the standard class period that I usually have to give students a test. And so I chose these problems, and I used to have more problems on here, more difficult ones, but the time was about an hour. And I, got some complaints that, students were late to class, things like that. And so I felt bad about that. So I made sure to adjust it so that the estimated time is less than 50 minutes for this test. And so one thing I cut out, which I'm not happy that I cut out, but it's finding the equation of a line that's parallel or perpendicular to another line. In its place, I put this question, which is a much shorter, quicker question, which is just find the slope of a line that's parallel to this line. You don't have to find another equation, just find the slope, right? Because we found the equation earlier in question number 9. This one's just find the slope, because you already kind of proved you could find an equation earlier. So I still feel like I'm kind of addressing all of the topics I need to, but one of my favorite questions is find the equation of a line that's parallel or perpendicular to another line. And I had to cut it out because it is a lengthy question. It takes up a lot of time. And so I ended up cutting that out because those things were addressed in other ways. All right. So how do I find the slope of the line that I'm given? I have to solve it for y. So this is another thing you're being tested on is, given the equation in standard form, do you know what to do with it in order to find the slope? You have to rewrite this equation and make it look like this. To go from this to this, oh, my arrows are terrible, you have to solve it for y. So the first step would be to add 2x to both sides. And I get 6y equals, I just leave it like this, -10 plus 2x. You could put, in this case, I'm really tempted to put the 2x in front of the -10. It would look a little better that way, but I'm just going to leave it like this. All right. Then to get y by itself, you divide by 6. And you're going to get, I think I have room down here, y equals, now this 6 has to divide into both of these. While that might not affect the answer you get for the slope, if you only divide it into the x, but you don't also divide it into the 10, I would take a point off because that's a mistake. All right, so we're going to get -10 over 6 plus 2x over 6. And we want to simplify this. So reduce this fraction. We get -5 over 3, right? Because you can divide a 2 out of both of those. Plus, reduce this fraction, it becomes 1 over 3. And then knock the x off to the side of the fraction just to make it fit that formula a little bit better. Right, and then we see that the slope here is 1/3. That is the slope of this line that we were given the equation of. We want to know the slope of a line that's parallel to this line. Now, it may sound like a silly question, but it's what I'm testing you on is, do you know what the slopes have to be for the lines to be parallel? And for them to be parallel, the slopes have to be the same. So whatever this slope is, this line that we want to be parallel to it would have to have the same slope. So I wouldn't say that, oh, this is my final answer. This is the slope of the line you were given the equation of. But for a line that's parallel to that given equation, you want to make a statement about what that slope should be also. And I'm sorry, it's really hard to read right here. I apologize for that. So let me write it down here. Well, I kind of messed up there. But this line that's parallel to it would need to have the same slope. So I think, now if you just stop here and you put a box around that, I'm going to give it to you. I'm not going to take off points for ambiguity here. But I think there's some ambiguity if you only have the slope written once when there's 2 lines in this equation, or not in this equation, in this problem, right? So question number 11 is a problem involving 2 lines, which each have their own slope. Now for parallel lines, those slopes will have to be equal, but they do each have that property And so really there's two slopes that need to be addressed. There's the slope of the line you're given the equation of, and then there's the slope of the line that's parallel to that given equation that you're trying to find the slope of. There's two slopes there that are being managed in this problem. I'm trying to think of a good word to use. So you don't want to just write the slope once, because then the ambiguity is which line does that slope apply to? The one that you were given the equation of, or the one you're looking for the slope of? So to avoid that ambiguity, you just write the slope twice. And that shows me that you know the slope is the same for both of them, and that there's two lines in the problem, and that you know the slope is the same for both lines. So that's the way I'd like to see the work. It'd make me feel more confident that you understand the concepts. But if you only put the slope once, I probably would just go ahead and let it go. All right. And you might say, well, why can't you just assume, if they have the slope and they put a box around it, that they understand? I've made that mistake before of assuming, based on what I see, that a student understands a concept, only to later find out they really didn't understand it. And so, and there's been cases where I've had problems on the test where I thought, oh, well, it's obvious. Like, why would I need to ask this? Because it's obvious from this answer what that would be. But then when I actually put it on the test, some students don't get the right answer, even though I thought they would. I thought it would just be automatic. And so you don't want to make assumptions about things as a teacher. So, all right. So here's some pretty easy problem. I mean, I say easy. One of the easier problems on this test, working with complex numbers. And so here we want to subtract. Now this one I said it was easy, but it's also very easy to make a particular mistake here. So be careful with it. You want to distribute the negative sign into the parentheses, and then drop the parentheses from the problem. So when I go to rewrite this problem, I won't have any parentheses in this problem anymore. The first set of parentheses never needed to be there to begin with. There's nothing mathematical going on with that first complex number. I shouldn't say that. Sometimes I just make up words, I guess. There's nothing mathematically going on with that first set of parentheses, is what I meant to say. But for the second set, there was something mathematical going on, which is there's a minus sign out here. And in order to get rid of these parentheses, we have to address that minus sign, which means we have to distribute it. But once you distribute it, there's no need for those parentheses anymore either. So we get negative 5 minus 4i. So make sure you apply it to both of them. And then you combine like terms. That's all there is to this problem. So we get 2 minus 5, which is negative 3. And then negative 3i minus 4i, which is negative 7i. And for whatever weird reason, I'm pretty sure this is the case. And again, I'm not telling you to memorize this answer to get the, for the test, because I want to see this work. But I don't know why they couldn't randomize the numbers here, because this is always the answer. It's always negative 3 minus 7i every time I give the test. So I probably need to pick a different problem where the numbers get randomized, because I think Math Excel dropped the ball on this one. They set this problem up, but they didn't randomize the numbers. It just gives the same numbers every single time. And so this answer comes out the same every time. All right. Here, you want to multiply. It's parentheses, but there's no adding or subtracting between them. And so you have to multiply these, and the directions tell you that as well. And to multiply these, you have to FOIL. First, outer, inner, last. So first would be 7 times negative 3, which is going to be negative 21. Outer is going to be 7 times negative 5i, which is negative 35i. Inner is going to be 2i times negative 3, which is negative 6i. And last is going to be 2i times negative 5i, which is negative 10i squared. Then the next step would be to get rid of the I squared and replace it with negative 1. Because that's the definition of I, right? I is the number that when you square it equals negative 1. So this is just simplifying that number. I squared is negative 1. And so we get negative 10 times negative 1, which is going to be positive 10. And then these combine together to give me negative 41i. And then this one I'll just copy down, it's negative 21. But then these now are like terms. So I'll combine those together and I get negative 11 minus 41i. All right, and so that's the answer to that one. Okay, let's take a look at number 14. So here you're simplifying these square roots. Remember, a negative sign inside of a square root, a negative number, how do I want to say this? The square root of a negative number is going to be imaginary. So the way I process this is the negative ends up being an imaginary number outside the square root. And so it becomes this. Sorry, I'm saying the wrong thing. I square root of 81. Now that the negative sign has been processed and dealt with, you simplify the square root that remains. Square root of 81, we know, is 9. So you get I times 9, which ends up being 9i. And that's maybe overcomplicating it. A lot of students are pretty good at just jumping to that, and I'm fine with that. So this is one of the problems where I think there's at least one step to show, but you don't have to show me all of these steps here. You don't have to do I first, and then square root give you 9, then get to that. You can just jump to 9i for this one. And then we have minus. And so what's this one become? Well, again, the negative there is going to make it imaginary, and then the square root of 25 is going to give me 5. So you can just jump right to that. But I still think this would be a worthwhile step to include, and then you combine those together to give you 4i. So if on the test you just had 4i, I think that's skipping a little too much because, there's this step that's kind of significant that should go in there. And again, it's not obvious right away that this just becomes 4i. There's an intermediate step. And yeah, could you do that in your head? Sure. I've had this discussion with students as well. They're like, well, I could do it in my head. I'm not asking you to write your work for your benefit. I'm asking you to write it for my benefit. I want to know how you thought about the problem. I mean, when I'm grading the test, I'm not just looking for right answers. I'm looking for how you're approaching the problem, your thought process involving the problem. And if you skip writing out your steps, even if you could do it in your head, I don't get a chance to see how you're thinking of the problem. And who knows, I've learned things from students, right? So by students showing their work, I learn different ways of thinking about the problem. So you could be teaching me something, especially if you can do a really complicated problem in your head. Please share that with me so I know, how you're doing it. So write it down anyways, even if you could do it in your head. So do it for my benefit. All right. Now we're on to 1.5 finally, solving quadratic equations. So the way we would solve this one is we can just solve it for z. It's quadratic because of that power of 2, but there's only one variable in the whole equation. So that means we can isolate that variable, move everything else to the other side. And that's going to start with getting rid of the power of 2. So to cancel out this power of 2, I'll take the square root of both sides. That square root cancels out that power of 2. I'll get z plus 5. I don't need the parentheses anymore. All right. Equals the square root of negative 49, which, again, maybe you've already figured out how to simplify it. I'm going to wait a second. Because there's one other thing I want to talk about, which is whenever you take the square root of both sides, what do you have to do? Plus or minus. All right, so let's go ahead and do that first. Then to get z by itself, we subtract 5 from both sides. And we'll get z equals negative 5. So I'll go ahead and put the minus 5 in front of the plus or minus. That's just the standard location for that number, is to place it in front. Plus or minus the square root of negative 49, which, like I said, maybe I should have already simplified it. I'm sure many of you already have, but because it was just like this problem up here, right? The negative makes that imaginary, right? The negative in the square root makes it imaginary. And then the square root of 49 is just 7. And so square root of negative 49 becomes 7i. The rest of this stays the same. And there are my two solutions, right? Negative 5 plus 7i, negative 5 minus 7i. All right, let's take a look at number 16. Use factoring to solve the quadratic equation. Check by substitution or by using a graphing calculator and identifying x-intercepts. You don't have to do that part. Just solve it. Checking your answer is a good idea to confirm that you got the right answer, but not something I'm going to grade you on. So if you feel confident that you did the problem right and you got the right answers and you don't want to check your answers, then you don't have to do that. But we do want to do this first part, solve this. And also it says, solve by factoring. But if you get a problem that you feel you're having trouble factoring, feel free to just use the quadratic formula. I'm not really picky about the method you use to get your answers on the test, as long as they are valid methods. And again, one method I am picky about is just memorizing the answer. That's not okay with me. But any kind of valid math you want to use to get the answer is fine. Just make sure you show your work. So if you have to use the quadratic formula on this one, that's not a problem. I'm not going to count that against you. But the easier way to do this problem is to factor it. So we need two numbers that multiply to negative 45 and add to negative 4. And those two numbers will go in my two factors. It's a shortcut we can use because there's a 1 in front of the x squared. So two numbers that multiply to negative 45 and add to negative 4 would be negative 9 and positive 5. Right? That multiplies to negative 45. Those add together to give you negative 4. And you just slap some x's in front of those and you have your two factors. And I should mention, in order to solve by factoring, it has to be equal to 0, which was already the case, but I forgot to mention that was important. Right. So we factored it, then we set each factor equal to 0. So I get x minus 9 equals 0, x plus 5 equals 0. And here's another one where students will kind of skip some of the details. And I'm flexible here. I would like to see maybe this much. I don't know, not even this much so much. Just the factoring would be enough for me. So if you have this problem and you just write the answer down, maybe you could figure all this out in your head. I feel like that's skipping a little too much. At least show me how you factored it. You don't have to put the details of it, but just show me how it factored. And then from there, it's pretty obvious to see what the answers become. Because to solve this for x, you're going to add 9 to both sides. And you get x, I'm running out of room here, x is equal to 9. And it's pretty common for many students to just skip from here to here. You just kind of take the opposite sign of that number and that ends up being the right answer. And I'm okay with that. I think you should write how it factored. And when I say how it factored, I mean you should write the factored form of this first. And then once you have it factored, then you can jump to the answer. And that's enough detail, I think, for this problem. So, with all the crazy stuff going on, maybe this is not such a good offer, but in class, if we're in a face-to-face setting, if you're not sure that you're showing enough work, just ask. I'll say, sure, that's fine. You've showed enough. Or I might say, could you put another step here so I have a better sense of what you're doing? Or just by talking to me about it and explaining, well, here's what I'm going from here to here. I'll remember that. And when I grade it, I'll remember I talked to the student and they explained to me what they did there. And that's sufficient as well. So all of those would be fine. However, on if it's not face-to-face, you're taking the test online or like in a proctored setting, and I grade it, because I'm still asking you to like put your answers on paper, show your work, all that stuff. If the work's not there, I may not give you credit for it initially, but if you want to talk to me about it afterwards and say, well, here's how I was thinking of the problem, this is how I got it, I would be happy to give you that credit back. So even if I don't give you credit for lack of work, I'm usually willing to give students a chance to fill in the details for me to get the credit back. The only exception to that might be is if the answer is wrong. So you just didn't show any work and you just have a wrong answer. I might say, where's your work? But I might not give you a chance to explain it anyways because you just didn't have the right answer anyway. So whatever you did there must have been a mistake somewhere. So I might not give you the option there. But okay. So those are my two answers. Sorry, I keep going off on that tangent, but it's our first test. I just want to make the expectations clear for you. If you're in my class, this is what I expect. I hopefully in the next review videos that I do, chapter 2, chapter 3, I'll just focus more on the problems themselves. So for number 17, it's another quadratic equation. They suggest using the quadratic formula, and that's really probably going to be the only way we can solve this one, unless you want to do completing the square, which I find most students aren't really keen on doing. For this, you have to get it equal to 0. So even for the quadratic formula, it needs to be equal to 0 first. But I'm going to do something maybe you might not have expected. Instead of subtracting 5 to the left-hand side to get 0 over here, which is the standard thing to do, I really, 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 really don't like a being negative. I don't like the first number being negative. When you plug that into the quadratic formula, it makes it behave in ways that I'm not used to. Ways that you might not be used to. And I find students really do end up running into trouble because they're not used to a being a negative number. And the quadratic formula has a slightly different behavior when a is negative. I mean, the math kind of has a different feel to it because of that. And it can lead to mistakes. So my advice would be get it equal to 0, but in such a way that a comes out as a positive number. And I think you'll have a safer journey from there if you do that. All right, so it's a little more work here, but I'm going to add the 5x squared to the right-hand side. And that way, a will be positive 5. And then I'll also subtract 6 to the right-hand side. And I'm going to get 0 on the left-hand side. So I will have 0 equals, going in order from highest to lowest power, 5x squared minus 6x. And then we have this, it's a positive 5, so it becomes a plus 5 here. And I think this is going to be smoother sailing for us. All right. We want to use the quadratic formula. You really need to know the quadratic formula because it will show up again. Now, the formula for a circle, you're really not going to... There's a little bit of it in Chapter 5, honestly. They do find a way to like bring it back up near the end of the semester and near the end of the course. So it does kind of come up again, but for the most part, you're not really going to be dealing with circles or the distance formula or things like that. But lines will show up again. We're going to be graphing lines again in Chapter 2. Quadratic formula is going to show up again just throughout the entire course. It can show up at any time, really. So just be prepared for that. All right, so A is equal to 5. B is equal to negative 6. C is equal to positive 5. Dump those numbers into this formula and solve your equation. So you get x equals negative b, which is negative 6. Right? There's a negative in the formula, but then b is negative 6. And I'm sorry, my b's and my 6's look very similar to each other. That does sometimes cause confusion. I hope it's kind of clear. This is a little more rigid here than it is right here. I hope that helps. Plus or minus the square root of negative 6 squared. I'm going to have to scroll over here because I'm out of room. Right. Minus 4 times a, which is 5, times c, which is also 5. The whole thing divided by 2 times a, which is 5. There's the solution. We just solved the equation. However, can't leave it like this. So we need to simplify. Minus a negative becomes positive, right? So we're going to get positive 6 plus or minus the square root. Negative 6 squared will be positive 36 minus, this is going to be 5 times 5, which is 25, times 4, which is going to be 100. So 36 minus 100, which is negative 64, over 2 times 5, which is 10. We've seen this multiple times on this test already. I don't know if it happens this much on every test. Maybe different versions have different outcomes, you know. And I'm not quite saying that the right way either, but you know, different versions of the test might have slightly different results, right? Again, number 17 on the test will definitely be a quadratic equation where you have to use the quadratic formula. But will it always give you square root of a negative number? No, not necessarily. It could. There's other possible outcomes there. But for this particular version of the test, square root of negative numbers has seemed to come up quite a few times. This is going to be 8i. Right? I'm not going to go through the details of that again because we've already done it a couple times. The last thing we need to do here is reduce this. Now, there's a couple ways to think of it. I'm not really sure the best way to explain this one. I guess we could just split it up. I think that's a pretty common thing students like to do. So you take the 10, you divide it into each term separately. So we get 6 over 10 plus or minus 8i over 10. This is not the only way to reduce it, but it's one way, and it's a good way. 6 over 10 reduces to 3 over 5, right? You divide a 2 out of both of those. Plus or minus 8 over 10 reduces to 4i over 5. Which you could also write as 4/5 I if you wanted to knock the I off to the side, but it's not required that you do that either. All right, and so that would be the two solutions to number 17. Number 18 and number 19 especially is going to be a fairly challenging one. And then we have some inequalities. We're really close to being done. So I was afraid this video was going to hit 2 hours. I don't think it's going to be quite that bad. So solve this equation. It's a square root equation with one square root. Now I will say number 19, I'm pretty sure is fixed as a 2 square root problem. I might be wrong about that too, though. I'm not 100% sure. There might be alternates for these. So these problems come from section 1.6, which are on miscellaneous equations. Square root equations were one type, and there was one square root equations and there were two square root equations. But there was also solving by factor by grouping. There were solving by substitution for quadratic-like equations. There were rational exponents like t to the negative 2/3 power equals 5 or something like that. Any of those I think can show up here. So this particular version of the practice exam happened to produce two square root equations, but I'm pretty sure other things are possible. So to get a sense of the different kinds of questions you might see for number 18 and 19, you should take the time to look at more practice exams on Math Excel. Even if you don't do the whole thing, just skip to number 18 and 19, or just skip through it and just look what's different about this one, and maybe work on the problems that are different from the ones you did before, just to get a sense of the variety of problems that you need to be ready for. Right? So for one square root equations, you get the square root by itself, which is already the case for this problem. Then you square both sides, because that power of 2 will cancel out that square root. And you end up getting x minus 3 on the left-hand side equals x minus 5 to the second power, which is going to be x minus 5 times x minus 5. Right. So be careful not to distribute that power of 2. This cannot be distributed into the parentheses because you are subtracting here. You have to take this, multiply it to itself twice. That's how you square it, which means you're going to have to FOIL. First, outer, inner, last. So we're going to get x minus 3 equals x times x is x squared. X times negative 5 is negative 5x. Negative 5 times x is another negative 5x. Negative 5 times negative 5 is positive 25. I get nervous skipping details sometimes, but with FOIL, I think most students are pretty comfortable with that. And I think that, if you're not, please let me know. Ask, and I'll explain it in more detail if you're one of my students. But if you're in college algebra, probably feel pretty comfortable with that whole FOIL process by this point. So I might just kind of skip the details on that unless I'm instructed otherwise by a student who would like to see those details. All right. Before I start moving things around, I like to combine like terms first. So I'm going to get x minus 3 equals x squared. These combine together to give me negative 10x. And then I have plus 25. So it's a quadratic equation, right? X squared tells me that. How do I solve a quadratic equation? It's just like what we did on number 16. We got to get equal to 0. And then hopefully, and I think most of the time I want to say I've never seen it otherwise, but technically it could be possible. We can solve it by factoring. That seems to happen every time. But it is possible that maybe you have to use the quadratic formula. But most of these that I've seen, all of them that I've seen, can be solved by factoring. So I wouldn't expect it to be otherwise here. So got to get 0 on one side, so I'm going to zero out the left-hand side. So I get 0 equals, we'll still have x squared. Combine these together, I get negative 11x. Combine these together, I get plus 28. And I'm going to try to factor this. If I can't factor it for some reason, I would use the quadratic formula. Again, we can use the shortcut here because a is equal to 1. So two numbers that multiply to 28, add to negative 11, would be negative 7 and negative 4. That multiplies to positive 28, adds to negative 11. Solve each of these. You get x minus 7 equals 0. I was really tempted there to just skip these details and go right to the answer, but, I should do as I say, not as I do. How do I say? That doesn't make sense, because then I'm doing as you should do. Okay, that was a misuse of that phrase, but I should go by my own standards. My standards were show your work, right? So I'm showing my work here. Add 7 to both sides to solve this for x. I get x is equal to 7. Add 4 to both sides here, and you get x is equal to 4. And remember, last thing you have to do for these square root problems is you have to check your answer. That is not just good advice or a suggestion. That is a mandatory part of the process for these problems. So my original equation, I kind of marked it up here, but let me rewrite it. Originally, we had square root of x minus 3 equals x minus 5. It's really common when you get two answers here that one of them works and one of them doesn't. However, it is possible that they both work, and I think it's possible that they could both not work. So we have to check both of them. And I can see what's happening here, that one will work and one's not going to work. So let's check x equals 7. We're going to plug it into this equation right here. So I'm going to get the square root of 7 minus 3, right? I'm plugging in 7 for x, equals 7 minus 5. I'm sorry, it's kind of hard to see that minus sign there. 7 minus 5. 7 minus 3 is 4. The square root of 4 is 2. That's the left-hand side. The right-hand side is 7 minus 5, which is also 2. So 7 checks out, works beautifully, right? Solves the equation, gives me a true statement. So 7 is a solution to the equation. 4, however, will not be. If I plug in 4 for x, I get the square root of 4 minus 3 equals 4 minus 5. The problem is that we're going to get negative, not in the square root, but that the square root needs to equal a negative number, right? We're going to get negative 1 here. Square root of, sorry, not square root, but 4 minus 5 is negative 1. Here, 4 minus 3 is 1. The square root of 1 is positive 1. So the issue is a square root never equals a negative number. Sorry, I drew that arrow to a funny place there. Square roots never equal negative numbers. It's impossible, right? So it doesn't matter what I get in the square root. You'll never make it equal a negative. You might say, wait a minute, what if I had a negative 1 here? Well, it'd be imaginary, but it's positive. It's a positive imaginary number. So whenever you evaluate a square root, it always evaluates to something positive, either a real number or an imaginary number, but always positive. The only way you can get a negative with a square root is for there to already be a negative there outside the square root. Then this would come out as negative 1, but there's nothing we can do to put a negative there. So this doesn't work. 4 does not actually make that equation true. Only 7 does. And so only 7 is the solution for number 18. All right, let's take a look at 19. In fact, what do we have left to do here? Let's skip 19 for right now. Let's do 20, and then I'll do 19 in this empty space down here because I've run out of room. So for number 20, it's an inequality, and to solve this inequality, all you have to do is solve it for x just like an equation. Get x by itself, move everything else to the other side. So I'm going to subtract 10 from both sides first. So we get negative 5. That's kind of weird. Get negative 5. Oh, I just can't do a 5. X is less than or equal to negative 15. And then we will divide by negative 5 on both sides. On the left-hand side, the negative 5s cancel out. We get x. On the right-hand side, negative 15 divided by negative 5 is positive 3. And then the inequality symbol, remember, has to flip around. So that's really one of the main things. Number 20, I'm pretty sure every time you're going to have to flip the symbol around because that's what I'm testing you on here. If you divide by a negative on both sides, you have to remember to flip the symbol around the other way. That's one of the things I'm testing you on, right? And so this would be the correct, how do you say, this is how you would solve the inequality. However, what I get a lot of students doing on this test is they'll say, okay, I solved it for x. They put that in the box here. They put it on the line, right, for fill in the blank or whatever. But that doesn't go here. The directions are very explicit. Type your answer in interval notation. That's what you're supposed to fill in the blank here with, is the solution set in interval notation. And it's in the directions, right? Solve the inequality. We just did that. Write the solution set in interval notation and also graph it. I find a lot of students do fine with solving. They might forget to flip the symbol around, but they solve for x, no problem. And they do fine with the graphing part, which is kind of weird here. If you look, I hope this doesn't happen when I print up the test, but you can kind of tell which one's the right answer because this one's a different shade of blue than the other 3. And that's actually the right answer. I hope that doesn't happen when I print up the test from this point. I don't remember ever noticing that. Now, I don't have a color printer and I don't make color copies. So this ends up being black and white when I hand it out. And maybe when it's grayscale, you can't tell a difference. But I think it's kind of funny that the 3 wrong answers are a light blue and the correct answer is a dark blue. Anyways, this is the correct graph, right? 3, we want numbers that are bigger than 3. So here's 3 on the real number line. This graph shows numbers that are bigger than 3, right to the right of 3. That's what's shaded in. And because of the equals to, we want to use a bracket. on the 3 itself. And so this graph is the way the graph should look. Notice they will try to tempt you with this one here, answer A, which is almost the right answer, except they're using parentheses when they should be using brackets. So that's pretty common that you'll have to know when to use parentheses and when to use brackets in order to select the correct graph from these multiple choice options. Because the right answer is going to be there twice, but one will be with the parentheses and one will be with the bracket. So you have to make sure you choose the right one out of those. All right, so I would recommend finding the graph first, which is what we just did, and then do the interval notation once you have the graph figured out. Because I think it's easier to figure out the interval notation from the graph. So here we're going from 3 to infinity, right? So we start with the number furthest to the left. That'll be the left-hand number in our interval. And then it goes to infinity. It goes forever to the right, which is infinity, positive infinity. And we always use parentheses on infinity. And so that would be this set of numbers in interval notation. This is saying all the numbers from 3 to infinity. We shaded in all the numbers from 3 to infinity, so it's the same set. All right. And so these are the 3 things I'm looking for on the test. That you solved it for x, that you picked the right graph, and that you write the answer as an interval and not just leave it as an inequality. All right, so let's go back to number 19 before I forget. And then after this, we have 2 more problems to do and we're done. All right, so the equation, which I can't remember what it was, I didn't really look at it very closely. Square root of y minus 13, and then we have 13 over. Okay, I think I can remember it. All right, let's scroll down a little bit further. Okay. Switch back to the pen. Square root of y minus 13 equals, not equals, I already messed it up. Plus the square root of y equals 13. I was eager to jump to that side so I can get that number out of my head. All right, so this was our equation. There's 2 square roots. And I want to say number 19, you might be stuck with that. There might not be an alternate for number 19. It might be 2 square roots no matter what. Because this is a pretty challenging equation to solve. And I don't think it'd be fair to have 2 different versions of the test where one of them has this, that's pretty difficult, and the other one has something else which will have to be easier than this, I would think. Maybe substitution problems are a little more challenging, and that might be equal difficulty, but I do try, like if there's alternate problems, I do try for them to be of equal difficulty level so that whatever one you get, it's the same level of challenge. I don't want students to think, well, that person got an easier version of the test than I did. And while there might be certain problems where that does happen, my experience is if one student gets an easier problem here, they usually get a more difficult problem somewhere else, and it evens out most of the time. But occasionally I will see a version of the test where I'll say, that one seemed a little easier than the other one, but it's pretty rare. So usually it's pretty fair, and whatever you end up getting, the tests are about the same difficulty either way. So anyways, still philosophizing too much about pedagogy and all that stuff. To solve a square root, an equation with 2 square roots, the first step is to get one of the square roots by itself, and then square both sides. Simplify, multiply it out, simplify it. Then you should only have 1 square root left. Get that square root by itself, and square both sides again. So we're going to have to square both sides twice. My advice is to get rid of the worst looking one first. So I'm going to leave this one by itself. I'll subtract the square root of y to the other side. We have the square root of y minus 13 equals 13 minus the square root of y. We will square both sides now. Square the entire left-hand side, square the entire right-hand side. The square root cancels out the power of 2. We get y minus 13 by itself here. The square root's gone. Right. On the right-hand side, it doesn't work out so nice. It's like we did before when we square both sides. You can't distribute the power of 2 here because you're subtracting. So you have to take this and multiply it to itself twice. So 13 minus square root of y times another 13 minus square root of y. And then you have to FOIL, right? So again, we're foiling. It's like the 3rd time we're foiling in this practice test. 13 times 13, that's the first. It's going to be 169. Outer terms be 13 times square root of y. It's negative, so positive times a negative will be negative. 13 times the square root of y is just going to be 13 square root of y. Same thing happens with the inner terms. We have negative times a positive, which will be negative. Square root of y times 13, you just put the 13 in front of the square root. So you get 13 square root of y. And then the last 2 terms get multiplied together. Negative times a negative will be positive. And then we're going to get square root of y times the square root of y. Now, when you multiply those together, a shortcut there is that a square root multiplied to itself makes the square root go away. The square root of y times the square root of y is just equal to y. You really need to use that shortcut in this situation. I guess it wouldn't be so bad if you multiply these together. You get square root of y squared. Well, then the square root and the power of 2 cancel out. But if it was any more complicated than this, and you multiply them together without knowing this shortcut, it can get messy. It can be hard to recover from going down that path. So, because ultimately the square root needs to go away. And if, like, what I'm saying is if, like, you have square root of y minus 1 times the square root of y minus 1. If you multiply those together, you get the square root of y minus 1 times y minus 1. You might FOIL that out. That's the wrong path to go down. It's not going to simplify the way it's supposed to, and you're not going to be able to solve the equation. What you want to know is the shortcut here, which is square root times a square root multiplied to itself just equals whatever's inside the square root. That's going to keep you on the right path and help you solve the equation. All right. Anyways, I'm digressing. I made the joke earlier. I was like, oh, I was afraid this is going to be 2 hours. Well, I felt maybe I'm just destined for this video to be 2 hours because I keep talking about things I don't need to talk about. Okay. Combine like terms first before you start moving things around. So we get 169. Now these are like terms because they have the same square root. Negative 13 minus 13 makes that negative 26. The square root part stays the same. All right. And then we have one square root left in this equation. To get rid of that square root, we have to isolate it. So move everything to the other side. We're going to subtract the y over and subtract the 169 over to the left-hand side. And this one's nice because the y's all cancel out. That makes this a much easier end to the problem than it otherwise could have been. This is going to be what? 182, negative 182 equals negative 26 square root of y. Again, get that square root by itself by dividing the negative 26 to the other side. And we're going to end up getting 7. So 7 equals the square root of y. To get rid of that last square root, we square both sides again, and we get 49. We get y is equal to 49. Even after all that work, you can't really trust that answer. We have to check to make sure it actually works in the original equation. So the original equation was square root of y minus 13 plus the square root of y equals 13. We're going to plug in 49. So we'll get 49 minus 13 plus the square root of 49 equals 13. 49 minus 13 is 36. The square root of 36 is going to be 6. Square root of 49 is 7. 13, sorry, I said the wrong number. 6 plus 7 equals 13. Right? This does actually equal this. So 49 works. So it's the solution to the equation. All right. So that's how you handle two square root equations. We have one last page here with 2 more problems. Let me zoom in first. And then we will be done with the review. All right, so let's solve this compound inequality. The first step is to get x by itself in both inequalities that you're given. So let's solve this one for x by subtracting the 8 to the other side. 4 minus 8 is going to give me negative 4. Is greater than negative x. I was just thinking it might have been better just to get x on the left-hand side instead of solving for it on the right-hand side. But here's a way we can still fix it. So let's finish solving for x. We got to get rid of this negative sign, so we divide by negative 1 on both sides. And we're going to get, I'm already out of room here, 4, positive 4. No, that's not really going to work. That's not enough room. I guess I'll do it right here. Positive 4. And we'll get x on the right-hand side, but because we divided by a negative on both sides, this symbol has to flip around the other way. Then, graphing this is more challenging when x is on the right-hand side, so what I like to do is flip it around the other way so x is on the left-hand side. So we'll get x on the left-hand side, 4 on the right-hand side. But when you flip an equation, there's nothing to worry about. You can just flip the left and right-hand side. It stays the same. But for inequalities, when you flip them around, the symbol has to flip around with it. Not because we're dividing by negative, but just because that's just the nature of an inequality. If you want to switch the left and right hand side, you're switching the bigger one. Let's look at it this way, right? 4 is smaller than x. So the smaller one's on the left hand side. When you flip it around, now the smaller one's on the right hand side. So since that's the smaller one, this is the bigger one now, which means the symbol needs to face the other way. So when you flip an inequality around, the symbol has to flip around with it. All right. So that's the first inequality. We have to do the same thing with the second inequality. We'll subtract 2 from both sides. And I'm going to write it over here. We get 0.5x. It's weird to have a decimal there, but I tried to pick a problem that wasn't too hard, but still addressed the concepts I wanted to address and had an answer that worked out the way I wanted it to work out. And this was basically the only choice. And I didn't like that it had a decimal number in there, but it was my only choice. Divide by 0.5 on both sides. Just use your calculator. It'll be fine. You're going to get x is less than 8 is what you end up getting there. You do not flip the symbol around this time because we didn't divide by a negative. We divided, but it wasn't negative, so it doesn't flip it around. And this is an and. So this is solving it for x. That's the solve part. Then it wants the answer in interval notation, and it wants to know what the graph is. So let's do the graph first. The way I would do this is I would mark 0. Here's 4. Here's 8. We want numbers to be greater than 4. So here's 4. The numbers that are greater than 4 are to the right of 4. No brackets because there's no equals to here. So we want to use parentheses on the 4. We also want numbers to be less than 8. So here's 8. I want numbers less than that. That's going to be to the left of 8. Parentheses on the 8 because there's no equals to. For an and, you want where these two graphs overlap each other because you want them to be true at the same time. They're true at the same time where they overlap. So the numbers between 4 and 8 make both of these inequalities true at the same time. So for example, the number 5, right? 5 is bigger than 4. 5 is also less than 8. It satisfies both of them. That's what you're looking for. So it's just these numbers here between 4 and 8 that satisfy both at the same time. And so this is your answer, right? And so you want to draw that as your final graph just between 4 and 8, parentheses on the 4 and parentheses on the 8, which means D is the correct graph here from 4 to 8. As an interval, you want to go from smallest to largest. The smallest is 4, the largest is 8. Parentheses on both of those just like you have in the graph. And so that's the interval notation that they want typed into the box here. All right. Or I call it the box because on Math Excel, it'd be a box shape, but on paper, it's a line. So that's the answer they're wanting on that line there. All right, last problem is an absolute value inequality. We have absolute value of x minus 2 is greater than or equal to 4. I really need a break now. This video has gone on for way too long. The first step is to split the inequality up. So we're going to split it up just like you would for an equation. We did this earlier in the video for the absolute value equation. You do the same thing for the inequality. The first inequality will be exactly the same as the original, but without the absolute value. So I'm just going to copy this down right here. Almost everybody gets that one right. The second inequality, the left-hand side stays the same. You don't make any changes, just like equations. You don't make any changes to the left-hand side. But you do have to change two things here. The 4 needs to be negative, just like it would if it was an equation. You'd make that a negative 4. But you also have to flip the symbol around the other way. So for inequalities, the symbol has to get flipped around in that second inequality that you write. Greater than is going to make this an OR. This will be an OR compound inequality. And then you just solve it as an OR, right? You solve it as a compound inequality, which means get x by itself. So I'll add 2 to both sides here. We'll get x is greater than or equal to 6. Or here I'll add 2 to both sides. And I get x is less than or equal to negative 2. And that's solving the absolute value inequality. That's what you should get. Then we want to graph it. So again, we'll graph both of them on the same real number line. Here's 0, here's negative 2, here's 6. Try to put those numbers in order, spaced appropriately. Greater than 6 would be to the right of 6. Because of the equals to, we use a bracket on the 6. Less than negative 2 is going to be to the left of negative 2. Brackets on that. Now you might say, oh, they're not overlapping. Is that a problem? No, because it's an or, which means you want to combine these together. Let's try that again. Combine together, or keep everything is another way to think of it. So everything that you just shaded in, you want to keep as your solution set. So I'm keeping all these numbers because with an or, you don't need both of them to be true at the same time. You're happy as long as one or the other is true. So any number that's bigger than 6, you're good with. Any number that's less than -2, you're good with. You're good with either kind of number. Either kind of number is a solution to this inequality. And so we just keep all those numbers. These are the numbers that are bigger than 6. So 7 you're happy with because it makes this one true. So it's good to go. -3 you're happy with because it makes this one true. So it's good to go. It doesn't have to make them both true at the same time. In fact, that's impossible anyways, right? And so which graph is correct? Now this one kind of bugs me because the multiple choice options are not very distinguishing. Or I shouldn't say that, not very distinguishing. The opposite of that. The multiple choice options do not give you really any options. There's only one answer here that looks anything remotely like what we should be expecting with this problem. So you can kind of figure out the graph without really having the right answer or knowing what you're doing. This is the only graph that looks like an or compound inequality. It's the only graph that looks like this kind of absolute value inequality. So that's the right one. Writing this as an interval, you want to write, there's 2 regions here you have to describe. So I'll just do it down here. This region, smallest to largest, will be from -infinity to -2, brackets on the -2. This region, smallest to largest, goes from 6 to +infinity. And then to show that you're joining those together as a single solution set, you put a union symbol between them. And that's how this graph should look as an interval. So that concludes the video on the test review for the Chapter 1 test. I'm really sorry about the length of the video. I hope you found both the problems informative and my thoughts on test taking informative. And hopefully with the next several review videos, I will be more focused than I was today. I apologize for that. Anyways, good luck on the test.